So here's your project: to analyze the physics of the motion of an object under gravity. And it's got 4 parts. So part number 1 is to use video analysis to analyze the motion of your object, frame by frame, and from that extracting the X and the Y displacement values. Part number 2, from those displacement values, calculate the initial velocity of your object when it left your hand or left the object. That is its horizontal and its vertical components. Use those in the equations of motion to predict its range, and then compare its range that you predict with the range that you actually measure in the video. Part number 3, use the analysis of your Y velocity to calculate its acceleration and a value therefore for G, acceleration due to gravity. And part number 4, well, that's kind of a bit of fun stuff at the end, an optional extra analysis that you might choose to do. But before you go, you're going to be doing this in groups of 2 or 3 students. Don't do what you usually do in groups though. Don't divide it up and go, well, you do that bit, I'll do this bit, and you do that bit. You're not going to learn a whole lot that way, and the whole point of doing this is to do some physics and have a bit of fun together, but to learn from one another. So rather than dividing it into different sections, all kind of do it and then check each other's work, evaluate each other's work. Oh, I love the way you've done that. Your diagram here is really clear. And try and put together something that is an amalgam of all of your best ideas. You are individually and corporately responsible for the accuracy and the quality of the analysis that you do. So work like a real team of scientists, checking each other's work, talking it through, working on it together as much as you can. Well, once you've got Tracker downloaded and installed, you're confronted with a pretty empty screen like this. Well, the first thing we want to do is we want to go and bring in our video. So I'm just going to import the little test video I made with the lemons and have a bit of a look at it. So here it is, and I press play. There's my wonderful lemon gun firing my lemon. So I want to find that frame, the very first frame, when it was free of the cannon, and I think it's about there. And then I want to find the last valid frame. You've got to grab these little bottom arrows here, these little, they're a bit tricky to grab. I want to bring that back until it's not bounced off the floor. There we go, forward one frame. And I reckon that's pretty much that. So now I've trimmed the video, and what I've got is I've got the motion of it in gravity when it's not touching anything else, and it's just a projectile in gravity. So that's excellent. Now I want to track something. I'm going to track a new point mass. So up comes these graphs, and what we want to do is we want to put a little cursor, we'll hold down Shift, and then you get this target, and you want to align that target over the center of the lemon, and it'll automatically move on to the next frame. And I'm not doing a terribly careful job of this. Just make sure that you don't get confused with the shadow on the background. Try and get it as central to that lemon as it's possible to get it. Nearly there. And of course you can zoom in the video to make sure that you've got your crosshairs marked at exactly the right point. So now I've got all of my data here, but of course this is nonsense. It's not at all calibrated. So first thing I want to do is I want to set up my coordinate system so that my Cartesian coordinates at a reasonable place, but more importantly than that is that I need to calibrate it. So I need a calibration stick. And those blue marks on the wall represent exactly some masking tape, and it's the outside edges of the masking tape, by the way, that represent exactly a meter. And I want to make sure it's 0 degrees there and it says a meter there. Okay, so that's pretty good, but I also want to calibrate it vertically. What often happens with video is the distance vertically and distance horizontally aren't necessarily the same. It can sometimes get squished in its aspect ratio. So I'm going to go a new calibration stick. For some reason it's decided it's 0.2 something or other a meter, but at any rate, or probably based upon the first one. So I'm going to drag this down here, and again I'm going to make sure that it's saying 90 degrees exactly as I can. There we go, and it's exactly to the outside edges of those, and I'm just going to just make sure that it knows that that's actually a meter. So now I've got my two calibration sticks. It's saying a meter, it's saying a meter. That's looking about right there. I've got all my data. So now what I'm going to do here is I'm going to copy that data, and I'm going to flip across into Excel, and I'm just going to paste it in Excel for now. So this is my time data. This is my X displacement and my Y displacement. So right now I want to work out, I want to write some formulas for my Vx and my Vy. I'm just going to do a quick sense check and just make sure that this makes sense. Well, you can't work out velocity in the very first time interval, because you need a change in displacement to do that. So you've got to start at the second one. So change in. Velocity is not displacement divided by time. It is the change in displacement divided by the change in time. So it's going to be this minus this. That's the change in displacement. That's how much the displacement's changed in that time interval. And then I want to divide that by the change in time, delta t. So it's going to be this minus this value here. And there is my x velocity. I'm going to drag that down. That's really interesting. Okay, so now I want to plot my x velocity versus time. So I'm going to select that, hold down Command, and I'm going to select that lot of data there, and then I'm going to insert an XY scatter plot. Okay, there we are. And then I'm going to right mouse click and go add a trend line. I'm going to display the equation on the chart and the R squared value on the chart. It's going to make that big enough so that we can actually read it. And look at that. It's around about minus 10.5. Well, it should be minus 9.8, so that's not too bad. But look at our reliability, 0.99. So there's some validity issues with my video. Vertical's not exactly vertical. But my reliability is not too bad. So it's a quick sense check, and then of course there's all sorts of data that I can do, all kinds of analysis I can do with this data. I can look at what's happening to the X velocity. That should be constant, but of course with drag in a real world it's not going to be constant. But that's the basics of how to bring it in, a video into Tracker, how to score it in a Tracker, and how to export it into a spreadsheet so you can start analyzing it.